Hello, welcome back. This is the extra video that is not required for lesson 5. I think it's 5.3. It's over rational expressions. And I left a few examples off. And so I make this extra video for those that wanted a little more help. So as you recall, we're finding the LCD because we're adding fractions, and fractions have to be cut into the same size slice eventually. Essentially, which is the denominator. So we need to know what our LCD is going to be. And so for these two fractions, we have to have a 5, an A, and a B. And from the first video, we kind of made a shortcut. We said we're going to multiply whatever your current denominator does not include from the LCD. So this first fraction does not include an A. So essentially, we can just multiply by the A and delete the denominator. And then on the second fraction, we can delete the A and include the 5B. Okay, so we have, well, we're going to still need the denominator because we're not solving equations, we're adding or subtracting fractions. And so that means we still need the denominator. But so we have 6A squared plus 35AB. Okay, the LCD for number 8. Hopefully you've taken the time to find what you think is the LCD. So they both contain an A, but we have to have A squared because you have to have the largest amount of A from each denominator. And then B cubed. And so A squared B cubed is my denominator. And I'm going to multiply what's missing. So in the first fraction, it has the entire LCD. So the first fraction can stay the same, which is 5. And the second fraction is missing an A and a B squared. So that's going to be 9AB squared. For example, 7 and 8 are the two extras there. But if we flip the page, we skipped example 13 here. So we're going to have to factor these to figure out what we need for the LCD. So if we factor that, we could actually, let's see, let's 3x. My initial is going to be a 3x and 3x here. And then this one is a difference of squares. We can see that right away. So it's 3x, not squared, 3x minus 2 and 3x plus 2. And so that's what I'm thinking. One of those will probably be part of this. So we need 8, and we need to have a difference of 6. So if I do a 4 and a 2, they need to multiply to make a negative 8. So one needs to be negative and one needs to be positive, but the bigger one needs to be positive for this positive 6. So if we have 2 times 3 is 6 and 3 times 4 is 12, the difference will be 6. So this one is going to be positive, the bigger one, and this one will be negative. So you have 3 times 3 is a 9 squared. Negative 2 times 4 is a negative 8. And then you've got a 12 minus a 6 gives us a positive 6. So my LCD is I just need to have one of the 3x minus 2, one of the 3x plus 2, and then the 3x plus 4. So that's my entire LCD. And so that is going to be our denominator. And the first fraction is missing only the 3x plus 2. And the second fraction is missing the 3x plus 4. And let's not forget that this is a subtraction. So let's just distribute for now in our next step here. So 9 times 3x is 27x plus 18, subtracting. I'm going to put this all in one big parenthesis. 6 times 3 is 18x and plus 24. So let's distribute through the negative here. So it'll be a negative 18x and a negative 24. So when we combine like terms, we have 27x minus 18x is a 9x plus 18 minus 24 is a minus 6 over 3x minus 2, 3x plus 2, 3x minus 4. And we always look to see if we can reduce. And if we can factor out, let's see if we can factor a 3 out of here. We have a 3x minus 2. So that means that factor cancels, which is something different. So we're actually left with 3 over 3x plus 2 times 3x. That's a plus 4. Sorry, plus 4. Just take a minute and look that over. From there. And then the last example is, that's two examples are example 14 and 15. Okay, so we are going to need to factor each of these denominators to find out what we need to include in our LCD. So I'm got x minus 1, x minus 4x plus 1, and then x minus, or x plus 3, x minus 1. My 3 overpowers, and here my negative 4 overpowers. And then here is going to be x plus 3, x plus 4. Okay, so my LCD is got an x minus 4, an x plus 1, an x plus 3, an x minus 1, an x plus 4. So the only one that was duplicated was the x plus 3. So we've got 1, 2, 3, 4, 5 pieces to this. So each numerator essentially is going to be missing 2 to 3. So the first fraction is missing the x plus 3, x minus 1, and x plus 4. And the second one is missing the x minus 4, x plus 1, and the x plus 4. And the last one is missing the x minus 4, x plus 1, x minus 1. Wow. So this is definitely going to take some extra paper here. So all of this multiplied together is going to be x plus 3 times x minus 1. I'm going to do that first. So I'm just working on multiplying these 3 binomials together. That's going to be x squared plus 2x minus 3 times the x plus 4. Okay. And so I'm going to distribute that through. That'll be x cubed plus 2x squared minus 3x. Distributing the 4, I've got 4x squared plus 8x minus 12. So x cubed plus 6x squared plus 5x minus 12. So that's the first one. So that's a negative 5 times all of that. X cubed plus 6x squared plus 5x minus 12. Plus 5 times, and now I've got to do this middle piece here. And so we've got x minus 4 times x plus 4 times an x plus 1. And that right there creates a difference of squares. So x squared minus 16 times x plus 1. So distributing that through, we've got x cubed minus 16x plus x squared minus 16. So that's x cubed plus x squared minus 16x minus 16. For the second one. So that goes here. So this is x cubed plus x squared minus 16x minus 16. And then the last one is 1 plus. And then we've got x plus 1, x minus 1 times x minus 4. And so that's a difference of squares times x minus 4 on the third fraction. And so this will be x cubed minus x minus 4x squared plus 4. And in descending order, that's x cubed minus 4x squared minus x plus 4. And so that goes up here, x cubed minus 4x squared minus x plus 4. And I'm going to not worry about my denominator at this point. I'm just kind of combining things. So when I distribute through, this is a negative 5x cubed and this is a positive 5x cubed. So that will cancel. And I'm going to be left with just this x cubed here. So x cubed. Then this will be a negative 5x, negative 30x squared. I'm going to write all the x squareds plus 5x squared here, and then a minus 4x squared. And then my x's, so a negative 25x, and this one will be a negative 80x, and that one will be just a negative x. And then I'm going to multiply through here. Negative 5 times a negative 12 is a positive 60. And then a negative 60, so those cancel. And then a plus 4. So it looks like I have an x cubed. I'm going to cancel it as we write them down. And then my x squareds here is a negative 30 and negative 4. So negative 34 and 5 is a negative 29 x squared. And then my x's are all negative. So 105, 106. So negative 106x plus 4. All over this huge denominator here. Oh, that one is just for fun. Would never ask anything that big. Okay, example 15 is much more lighthearted. Here are those from example 14 if you're still kind of catching up. So example 15, this is over 1. So my LCD is very simple on this one, 3x plus 4. My first fraction is missing the 3x plus 4 times the x, minus the second fraction is perfect, plus the last one is missing the 3x plus 4. So if we distribute, we have 3x squared plus 4x minus 5 plus 3x plus 4 over 3x plus 4. So this simplifies to 3x squared plus 7x minus 1 over 3x plus 4. And this trinomial cannot factor into anything. So that is the end of the extra video. Touch me back for more.